going to move on to Alba Cáceres Rodríguez, who is going to talk to us about prolactin-induced changes in primary auditory cortex plasticity. This is her master's work that she did under Eduardo Martin Montiel, and she is starting a 6-month fellowship at AIX Marseille. So congratulations, Alba, take it away.
I'm gonna share my presentation. Okay, here it is. You see it? Can you see it?
Yes. Mm-hmm.
Yep, perfect. Thank you for the kind introduction. So my project was titled Prolactin-induced changes in the primary auditory cortex plasticity. And first of all, sorry. First of all, we should keep in mind that during pregnancy and lactation, there are multiple adaptive changes that take place in the maternal brain that are essential for the offspring survival. So this remodeling of the brain is in part promoted by hormonal factors such as oxytocin, but also prolactin, which is also involved in breastfeeding. This remodeling can also be promoted by sensory stimuli such as odors and vocalizations. So when talking about vocalizations, rodents in the first weeks of life emit different types of vocalizations. The most studied ones are the ultrasound vocalizations, and it seems that maternity improves the recognition of such. However, in my project, we have focused on another type of communication that takes place at a lower frequency range, and it is called wriggling calls. And apparently, pups emit this type of wriggling calls to attract the mother's attention during lactation. So the role of prolactin in the remodeling of the auditory cortex in response to wriggling calls is unknown. So the aim of our project was to find out whether prolactin was capable of causing changes in the plasticity of the primary auditory cortex in a model of hyperprolactinemia. So to do that, we performed chronic electrode implants in female mice in the primary auditory cortex. And these implants allowed us to record auditory evoked potentials that were recorded in awake animals. And these female mice were under a treatment of domperidone, which allows us to have a hyperprolactinemia model. And while recording the auditory evoked potentials, we would play auditory stimuli that could be either wriggling calls or pure tones of at different frequencies. And to analyze these auditory evoked potentials, we used methods derived on the Fourier transform. So the first thing we did was to check the effectiveness of our model of hyperprolactinemia. And when we looked at the weight of the uterus in domperidone-treated mice, we could see that that uterus was significantly higher. So we were seeing a change due to our treatment. After that, we continued by analyzing the response induced by auditory stimulation. And here, what we could see is that basically what we saw is a modification in the auditory response evoked by wriggling calls. So when we were stimulating with wriggling calls, we could see that the auditory evoked potential recorded change. This change was the most significant at day 7 of treatment with domperidone. And what really happened is that female mice treated with domperidone showed a significant reduce in the fundamental frequencies that are between 0.1 and 20. And these fundamental frequencies are like part of the spectrum of the auditory evoked potentials. So these were my first experiments in this group, and this is like a very preliminary study, but yeah, it would be nice to do the same with more animals. And also, due to the type of recording we made, we don't really know where in the whole auditory pathway the change took place. So it would be nice to register at different state points in the auditory pathway. And either way, I would like to conclude by saying some things, like highlighting some things, such as that in this hyperprolactinemia model, immature nulliparous awake females, we have found a modification of the activity in the auditory pathway in response to reading calls. So not only our study highlights the important role of prolactin as a modulator of the auditory pathway activity during lactation, but we also focused on another type of low frequency mother-pup communication, which are these so-called wriggling calls, that has been little studied and seems to be really relevant for a better care of the offspring. And yeah, I would like to thank my lab at the Instituto Cajal, and thank you all for listening.
That was awesome. Thank you so much, Alba. Do we have, feel free in the audience to submit questions. I will go ahead. This is particularly interesting to me. I have a 5-month-old son upstairs, so I can really sympathize with these mice and their sensitivity to wriggling calls. I was wondering, what was the reason that you took, that you were interested in the low frequency sounds, like as opposed to the high frequency sounds that offspring can produce?
Like usually, when we are talking about communication in mice or in rodents, everybody focuses on ultrasound vocalizations, because those vocalizations are present in the life, like the whole life of the rodents. However, wriggling calls are like a certain type of communication that is only present in the first 2 weeks of life of rodents. And we have to keep in mind that in these first 2 weeks, these rodents are really sensitive, and they need to attract the attention of the mother during lactation. So to me, it was maybe the most logical idea to do this test with this type of wriggling calls, because usually pups that emit ultrasound vocalizations, they do it when they are isolated. However, this is like the communication they use when they are lactating. So if we want to have like a lactation model, then it's better to have like a lactation communication.
Perfect. And there's a similar question from the audience. How do you know low frequency wriggling calls are important for pup care?
Because I read it. Like personally, I didn't check it, but I read it that apparently when the pups emit them, the mom tends to move the rest of the pups and let them like breastfeed. But it's a very old article. I don't read.
So we have a little bit of time. So, oh, that question just got answered. Never mind. Are there any other questions from the audience? Panelists, questions for each other? Otherwise, this was great, and I really appreciate you guys taking the time to give us this information. That's super cool.
Thank you.
Thanks for hosting.
Yes, thank you.